My name is Terrie Simmons-Ehrhardt, and this video is part 2 of a workshop called Meshlab for Virtual Osteology for the Virtual Osteology Conference 2021 hosted by BioantTalks. The second video covers a basic workflow for processing 3D surface scans in Meshlab, including editing, aligning, merging, and making a watertight mesh. There are many variations on this workflow depending on what you're scanning, how many scans you have, and whether you want to work with textures or vertex colors. But this video presents the most basic tools and workflow to get you started. If you're collecting surface scans, whether it's with the NextEngine or some other scanner, sometimes you might have some issues with the processing software. Maybe it's a little slow, or you have a hard time processing models with the color, or you just don't like it and want an alternative. Meshlab is that alternative. As long as you can export your scans as one of the common 3D file formats, usually if you have color, it's going to be PLY or OBJ, then you can export those scans and finish processing them in Meshlab. You can export them at any point in your scan process. So for this example, I have, this is a little vertebra. I think this was from a package of like oxtail soup. So, but it has some nice features that will be good to demonstrate. So I have two scan families for this, and I went ahead and edited out the scan fixture. This was from Scan Studio. And Scan Studio especially is really, really slow when you try to process. And I don't even like the color usually that it spits out when you hit fuse. So Meshlab does a much better job of blending your colors between layers. So I've exported these out of Scan Studio, and I'm just showing one scan family right now, which is A, family A. So I named it this way when I exported it. And this was 16 divisions, so I have 16 layers here. And you'll notice, the first thing you notice is that the scan itself, so the 15 from the one family, they're all aligned to each other, although not necessarily perfectly. The first thing you notice is that it's dropped kind of down here to the bottom. Well, that suggests to me that there are some alignment points floating around at the top of the model. So also, each of these layers consist of vertices and faces. So in order to find those alignment points, I'm going to switch to point cloud view. And remember, you can hold shift and click the point cloud view on any one of the layers, or even down here I think would work. And there are my points there. I'm going to enlarge the points here on the right hand dialog so I can see them a little better. Oops, I should have hit shift. Shift and enlarge so they all get bigger. There we go. So I have all these points right here. I'm going to get rid of that trackball. And I'm going to, let's see. I don't feel like exporting all 16 layers for editing these points, so I'm just going to delete them. I do have all 16 layers. Okay, so I went through and deleted those alignment points for each layer. If you only have like 8 layers, then it's not such a big deal. This was kind of a pain since I had 16 layers. But there's not really any way to control that. Sometimes those points are there and sometimes they're not. So taking a look at this, we have a few holes and we don't have a whole lot of ugliness, but I'm going to show you how to sort of edit single layers if you want, and then to remove some of the ugly colors. And so if you hold the shift key, then you can apply, then you can adjust visibility or whatever to all of the layers. So I'm going to hold shift and click on one of these eyes to make them all invisible. And then I can look at each one at a time. And if you see some stuff that you want to remove, there's a couple ways to do that. So in order to remove those alignment points, I used this Select Vertices tool because those were just points. If you use the Select Faces tool and they're actually points, then they're not going to disappear. So you need to choose the right tool. The second one is Select Faces in a rectangular region. The third one is Select Connected Components in a region. And the fourth one is Select Faces Vertices inside a polyline area. So this will let you draw sort of an irregular area. I'm just going to use this little rectangle tool for now. That one was the Select Faces. I'm just going to select this little bit that's from the top because that's going to be captured in a different scan family. To delete it, I'm going to select this last button, delete the current set of selected faces and all the vertices surrounded by that face. There we go. We'll export the layers as a newly edited layer because they're not all going to need editing. But usually I do that way I still have the original scan and I have my edits if I like them. And then because these are aligned, you can kind of go around and see which ones need some editing. So what if you have a much smaller area? These little edges, you know, there's all these dark colors along the edges here. If you want some finer editing control over that, besides just drawing the rectangle, we can use this paintbrush tool. It's called Z Painting. And this new box pops up. So this does give you the option to do some color painting if you needed to on your final model. But we want to do paint select. So we're going to select this red paintbrush down here. And you'll see that it gives you some options. All you really need to adjust is the size of the brush. So when you're getting all of these little edges here, you know, you might want to make the brush a little smaller. I like this little round brush. And then you can click out of the brush, or you can just click that delete button, delete the faces and the vertices, and you can move it around, find some more little areas to delete. And then remember to export it. I usually add ED. So there's still some dark edges there that normally I would go through and delete. But if you're happy with it, then we can now combine all of these. Again, you don't have to combine all the layers from one scan family into one model if you don't want to. If you would rather divide this up, especially with some larger bones or like skulls, you might want to group them together based on you know, anatomical direction or features. So to combine layers, I'm going to go ahead and combine all of these because they look to be aligned okay. I'm going to right click on any of the layers that are visible. So any of the layers that you want to include, make sure they're visible. Sometimes you might end up with a layer or two that really just don't contribute anything, like, you know, maybe they got blocked by the scanning pole, so not very much data was collected. So if you don't want to include any layers like that, then you can just make them invisible and they won't be included. So when this new menu pops up, we're going to select Flatten Visible Layers. And so this doesn't create a watertight mesh. All it's doing is combining all of these layers into one. So that's what we want to do. Go ahead and select Keep Unreferenced Vertices. And all of these, we want to go ahead and delete the layers. So I'm going to click Apply and close that. So now you see all of my individual layers have been deleted, and now I have a merged mesh here. So we can export that as, I'm going to call it a merged. And you'll notice we don't have anything on the superior and inferior surfaces because that would be scan family B. So now I need to work on that. So now I've brought scan family B in here. I haven't done any editing except to remove those stupid alignment dots. There's a few little ugly surfaces here, but I'm going to go ahead and merge them. So right click on one of them, flatten visible layers, keep unreferenced vertices. Okay, and then I'm going to export this. You should get in the habit of just exporting frequently. And, even if you go back and make some edits, I always just go ahead and export as soon as I merge, and then, and then I might go back and do some of this editing. Now I have my two scan families that were merged, and I need to align them to each other because they're not aligned to each other because they were, scanned separately. You can also use alignment for those individual layers if you wanted to, just like in Scan Studio, but again, you have a little bit more control. You don't have to stick with the family groupings. You can break things out of the families and align them. So for this, I'm just showing sort of the simplest case. Like your scan families look to be aligned okay, you just need to align them to each other so that you can get your watertight model. So the align tool is here. It says big A with the yellow circle around it, and a new window pops up. It automatically converts the models to false color, but I'll show you how we can adjust that. So one of them, choose to just glue there, so we'll just select A, and then we'll click on B, and you'll notice that these other buttons popped up. So manual rough gluing or point-based gluing. So we're going to go point-based gluing. And this new window pops up. Again, the models are in false color. You can move each one of these separately. We can turn off the false color. Down here at the bottom, there's a checkbox that says use false color. You can turn that off. And it just depends on your model. I prefer to usually turn off the color because especially when you have all these overlapping scans, it just looks kind of bad. So this way, using the false color forces you to look at morphology and look for features and shapes that are actually matching. So you have to place a minimum of 4 points. And usually what you do is you find a point, so you would orient the models until you find something in common that looks like you could identify easily on both models. And then you double click. I usually just go left to right. I double click on the first model and it drops a 0. It starts numbering from 0. And then double click on the second model, the corresponding point. And you don't have to be super crazy exact because it's going to take all the points into consideration. And just kind of keep rotating around until you find some places that look good. Let's see. And I try to spread the points out so they're not just going in a straight line around the model. I try to spread it out in 3D space so we're representing different parts of the model. If your models are moving slowly, then you might choose to use point rendering. That can help if things are just kind of moving around really slowly. If for some reason you think that the models might be at a different scale, especially with photogrammetry, that might possibly happen, then you can allow scaling if you know one of them is at the right size, but the second one is not. And so when you're happy, then just click OK. And you'll see that before you even do anything, it automatically sets some sort of alignment. It does apply some sort of alignment, and we can see the transformation matrix down here. To refine this alignment, we're going to hit Process. And then it goes through computing a little bit finer alignment. If you want to copy this text out, you can if you want to save it. Let's close this out if everything looks good. If for some reason it did not look good, then you can always redo it. You could just say unglue the mesh whenever that's there. You could unglue it and then do the alignment again. But this looks pretty good. And you'll see that the first model did not move, but the second model moved to fit to the first model because this transformation matrix here is not set at identity. So in order to lock that in place, if we like this, then we need to right-click on B, the model that moved, and we want to say matrix freeze current matrix. So that's going to lock in that movement. There you go. And then I would go ahead and export that as well. And I would call that like align to A. Okay, and this is still in false color, so let's go ahead and adjust that here by going down to the solid mesh and hold shift and select vertex color, so it switches both of them to vertex color. Cool. So now we can merge these two to each other. If you're happy with it, which for our purposes we are, right-click on one of the layers and select Flatten Visible Layers. Go ahead and keep unreferenced vertices, just do all of that, keep everything there. And I'm going to export this as Calvert, A plus B. Now we need to make this a watertight mesh. And you see that there are still some little holes here, so I probably should have collected another scan family. But let's just see what happens with this. So to make a watertight mesh, we're going to go Filters, Remeshing, Simplification, and Reconstruction. That's a big menu, but go down to Surface Reconstruction, Screened Poisson. So you can kind of think of this as basically wrapping your model. And if the holes are not too big, it will fill them. So that's not a big deal. If the holes are big, it's going to try to make a guess. If they're too big, then you're going to get some wacky results. But you can always delete the wacky parts. And so this is usually what I run this at is at 9, a reconstruction depth of 9. The default is set to 8. We can try it and see how it looks. It's probably going to look too low resolution. You'll also notice that this has an option to merge all visible layers. So technically you wouldn't have to flatten the layers the way that I did, but I found that it's just a little bit easier to do that because there's like a read-write issue. If you see this here, the warning here, and if I merge it, then I don't have that problem. So let's just go ahead and click Apply. And it really doesn't take that long. You know, when you hit Fuse and Scan Studio, you kind of basically just can go get a snack or something. And then you don't know what you're going to get. So here's our new layers popped up. It's called the Poisson Mesh. And you'll see the color automatically got blended and transferred over. The holes are filled in. The resolution of this is a little low. Our original mesh was 789,422 points. Of course, that includes a lot of overlapping points. So you do expect it to go down. But 177,000 is pretty low, but it might be enough depending on what you're doing. You see that a little floaty bit happened here, which can happen. So I always run a cleaning step. So you go Filters, Cleaning and Repairing, whoops, and remove isolated pieces with respect to diameter. You can leave the default. I just start with the default. Go bigger if you need to. Down here in the text output on the right, it says that it removed 2 connected components out of 3. So there were actually 3 total components. It removed 2, so we're left with one solid watertight mesh. It also removed 205 unreferenced vertices. So if you're happy with this, you could save this as a new mesh. File, Export Mesh. You can call this Calvert We did a Poisson 8 just for, sometimes you don't need the quality, we just need the color and the normal. So sometimes you might want to compare it. So let's make that Poisson mesh invisible and make our original visible again. And let's try running the reconstruction, the screened Poisson reconstruction with a reconstruction depth of 9. Check the pre-clean box and hit apply. It's going to take a little bit longer, but it's good to do. You know, you might even need to go up to 10 depending on your model. So it's nice that it's pretty fast so that you could generate models at different settings to see how they look and compare them. There we go. A new layer popped up. See that it named it Poisson Mesh 1 in parentheses. So this has many more points. It's up to 706,000 points. The colors looking okay. It's a little bit noisy. There's definitely more detail, but there's also a little bit of noise. So that's one of the things you need to be wary of. But if you like this with the color and all, let's go ahead and run that cleaning step. So it removed 32 connected components out of 33. So again, we're left with 1. If this model size is still a little big, but you like the color much better, then you could always just run a decimation step. So for example, if this is too big for you to put up on Sketchfab or whatever you're going to be doing with it, oh, you'll see that piece that was in a little floaty bit before got connected here just barely. You could delete that if you wanted to. And then let's just go ahead and do that. I'm going to use the paintbrush to select it, maybe. Let's try that again. There we go. Oops. Undo. Get this from the front side too. Take that little bit off. But now I've also left a little hole. So I'm going to have to fix that. You can see all this roughness here. There's a lot of noise, but now I get to show you the hole filling. So let's go filters, remeshing, simplification and reconstruction again, close holes, and just enter, let's just enter like a really big number, 500. And because I told it to select the newly created faces, so where it added some faces to fill in the holes is selected red. So we can click off that red to see how it looks. So if you wanted to do some smoothing or just decimate, remember decimating is going to do some smoothing. So, oh, you'll see how it filled in the holes here. How it still tried to stick as close to the model as possible instead of creating like a giant bubble. But the bigger the hole is, the more bubbly it's going to get. Okay, so filters, remeshing, simplification and reconstruction, simplification, quadratic edge collapse decimation. Make sure to check preserve normal and preserve topology. The target number of faces, the default is usually half of whatever the mesh you have selected has, and then click apply. Okay, so now we have a mesh that has, you know, roughly still the same color that it had, but it's decimated now by half, so that's kind of nice. And there was a cleaning step, but included in the decimation, but you know, it doesn't hurt to run the cleaning step again. And just make sure it says removed 0 connected components out of 1, so it's totally fine. So this then you could export, you know, if you wanted to call that 50% decimated by 50% now. And you still have the color and it still looks pretty nice.